Hyperfiddle is a tool for building CRUD apps. It uses data schema to drive composable UIs by leveraging an immutable database. And surprisingly, it also reduces the complexity of building apps by using a compiler to manage the network for an application developer. And so as a result, there's no front end, there's no back end, there's only, I guess, what you could coin the word as the app end. There's just an end, I guess.
I think it's with Hyperfiddle as it is with the demos that they've given, I think it's exciting because, again, the whole home-cooked meal type apps, there are a lot of apps that I think should exist that will exist with tools like this. And then with our extrapolation into what does this mean for programming generally.
Hi, this is Will, and I'm a YC alumni and an independent researcher who's worked across e-commerce, cryptocurrency, and financial industries.
And I'm Shri. I'm a YC alum and a research engineer focused on natural language processing for search.
Welcome to the Technium, where we talk about the edge of technology and what we can build with it. An optimistic look at the road ahead. How's it going, Shri?
Pretty good. How are you doing?
I'm doing all right. So it's been a long week for you, I take it. And are you glad to be able to settle down with your drink?
Oh, yeah. And it's also a very cold day, but I have a very cold drink, so a kind of strange combination, but I'm excited nonetheless.
Oh, cool. What'd you got this week?
I have this Liquid Death sparkling water. Yeah, this has been trending for a while on the internet, and apparently, despite the gimmicky branding, is a high-quality mineral water. So, yeah, I'm gonna be tasting it today.
Yeah, when I saw it, I was just like, oh, they decided to go negative with the branding. Like, might as well call like a sparkling water, I don't know, like rain mud or something like that, and see if people buy it.
Yeah. What do you?
Yeah. So funny thing is, I also have some water, sparkling water, but mine is also from Whole Foods. Waterloo sparkling water, peach flavor.
That's cool. Peach flavored, huh?
Yeah, we'll see. I don't know. Maybe it's different.
Yeah. We should do a drinks recap episode one day.
Yeah.
Anyway, yeah. What are we talking about this week?
This week we're talking about Hyperfiddle. Have you heard about Hyperfiddle before?
No, it's actually my first time seeing it, but it looks pretty cool. What is it?
So Hyperfiddle is a tool for building CRUD apps. It uses data schema to drive composable UIs by leveraging an immutable database. And surprisingly, it also reduces the complexity of building apps by using a compiler to manage the network for an application developer. So as a result, there's no front end, there's no back end, there's only, I guess, what you could coin the word as the app end. There's just an end, I guess. So.
Wow, that's quite a new terminology.
You heard it here first, right? Yeah, you heard it here first.
That's cool.
Yeah, so Hyperfiddle right now is definitely like early technology. Like, I think a lot of the other ones that we cover, it's relatively mature in the sense that like there is a community that's sprung up around it, and Hyperfiddle is even further out. Like, they're starting to build a community, but the reason that we picked it this week was because we thought that they had a very interesting take on how to build apps, and it's leveraged off of the unique ideas that are in the Clojure and the Clojurescript community. So how familiar are you with Clojure yourself?
I've actually written a few toy programs in Clojure.
Really?
And, yeah. I'm a bit of a Lisp fanboy. It was the first programming language that I ever learned. I learned Scheme in college. So
yeah. Was that your 101 class?
Yeah, it was.
Oh yeah. Same here. Although I don't think I really appreciated it at the time.
Yeah.
So like I'm a little surprised because usually the things that we cover, I'm like, have you used TLA plus? No. But then apparently like we covered it pretty well for two guys that never really used it, according to our listeners. So yeah. But yeah, this time around, it seems like you have some experience with it. Have you heard a lot about Hyperfiddle? Because I'm excited about two major things that it provides. Do you want to take a stab at it, or shall I? I think I'll go since I'm so excited.
You should go. Yeah.
So number one, Hyperfiddle, it lets the programmer generate UIs in a data-driven way. And it's able to do this because it leverages the Datomic database, which is an immutable database. An immutable database just means that all records are appended. It's never updated in place. That means it never deletes anything. And so as an aside, my favorite example is that when you have a database record about the current president, you don't erase any of the previous presidents. You just add a new president at the end. So current president is Biden, and then all the previous ones still stick around in the database, right? And so it is for any other record. And so in that way, clients of this database are able to have a local view of the entire database. That means that you don't need to make round trips to the database to fetch stuff. And so that means that when you have data-driven UIs, if you have a blog post with comments that have authors with pictures, then you don't need to make round trips to do extra fetches for those extra joins, right? Does that make sense? It's the same problem that like GraphQL solves, but it solves it in a different way.
Got it. Yeah.
At least on the back end. On the front end, it mostly resembles each other, although the query language is different.
Yeah. Okay. So Hyperfiddle makes use of Datomic, and what does that let it do?
So it lets it make queries that can traverse the object graph without making multiple round trips to the database.
Got it. Okay.
Right. And so therefore you can just join stuff willy-nilly and make generic UIs just simply by talking about which parts of the data schema you want to look at. So that's number one. Makes sense, right? So the second aspect of Hyperfiddle that I think you, Shri, are also very excited about is that it uses a compiler to manage the network for you. And so what that means is that you can write your program with both the client side and the server side in the same program, and you don't ever have to worry about the IO boundary or the network boundary. Like you don't have to worry about like doing the exact query and then sending it over a wire in a particular format and then picking it up on the client side and then like manually tying it to whatever UI that you're doing. Basically, like you just say, I want this piece of data in this object graph, and then iterate through it and then stuff it into these particular UI components, and that's it. Like you don't have to worry about the network, you don't have to worry about error handling, you don't have to worry about async await. All of that is handled for you. And so that's what it means to have a managed network, and all of that is the compiler. That's like it compiles that into something else that has all that code for you. That's pretty exciting, isn't it?
Yeah, I mean, I think the process of doing all of that manual work that you just described is basically my entire experience with web development or full stack development.
Yeah, like you think that, oh, this is what it's supposed to be. So like for a long time, I'm just like, well, this is the work, right? Like I didn't really think too much of it. And I think that's why, like when you look at Hyperfiddle and somebody points out the blindingly obvious thing that, hey, like maybe you don't have to do this work. Like maybe you can have a compiler do this work for you so that you can actually go do something else. That I think that's the kind of the slap on the forehead moment for me.
Yeah, so I got really excited when I looked at the Hyperfiddle demo video that they gave a talk at Hi Trad Boy. Have you tried rubbing a database on it conference?
Yeah, the conference, yeah.
Yes, and
we'll link to it in the show notes, but it's pretty exciting. It goes by pretty fast. Like one of the things about Magic is that you have to make sure that people are there so that they can follow you. So you do have to follow along closely to see the magic.
Yeah, you do have to pause a bit, but the basically the summary of that video is that Hyperfiddle uses, like you said, this domain-specific language called Photon, which can basically be compiled such that you can interleave the computation that happens on the front end, such as updating DOM elements and taking an input from the user and things like that. And you can interleave that with the things that should happen on the back end, for example, querying a database, and write it as though it's happening in a single program, in a single function. And this compiler goes through the function tree and then basically colors the parts that should happen on the front end and the back end and splits them up so that they happen in the right places, and then also manages the coordination between these two such that the client waits for the results from the server and vice versa, all magically seamlessly. That, like, basically it's doing a bunch of the stuff that a full stack developer would do, but just magically.
So one of the things that really stood out to me when I saw this also was when we talked about distributed systems, such as in our Corba episode. Like a lot of times people try to abstract out the network using RPC, and it just does not work. Like if you try to model RPC calls like functions, you're going to end up with a lot of pain. And, you know, like we've come up with the actor model and kind of we settled with REST, which is yet another type of RPC, but, you know, it seems to have worked kind of, you know, but for the most part, we just kind of lived with it. And so this attempts to show a new way forward. And it is early, but it seems really promising, right?
Yeah, it's quite a claim to make that this compiler can basically take arbitrary computation and then split it appropriately across a network boundary and handle the communication between all the sides, because I mean, that's basically what everybody in the distributed systems community has been working on for, I don't know, the last several decades.
Yeah.
The way that the video describes it, it was like, oh yeah, we just sort of applied DAGs and compilers to it and magically it's solved. And so it's a very, very compelling claim to make. I am like slightly skeptical that this applies to all arbitrary computation. I am curious about what are the limits of this method, but regardless, for the example that they showed, and certainly maybe for the use case that they're going after, which is to build CRUD apps or reactive UIs on the web, it seems like a compiler could do most of the work that people are doing manually.
Yeah, and so to give a general outline of what they attempt to explain in the video of how they do this is that because they're using a functional language and it's a Lisp-like language, so it's pretty easy for them to get the AST of the computation. They're able to convert it to a DAG. And this DAG includes both commands on the client and the server because, like we mentioned earlier, the code can talk about what both the client and the server need to do in the same line of code. And so when you generate this DAG, the claim is that for any computation that they have, whether it has loops, whether it has closures or functions, like the compiler is able to cut a seam through that DAG so that it cleanly separates what the client needs to do and what the server needs to do. And from there, it'll generate the network boundary and handle the requests across that boundary. And so that's effectively what the claim is.
Yeah, and I think that it makes sense that it would work for constrained use cases. And it's really cool because if you look at the example code, like you said, it has for loops in there. It has, it's making use of the full language. This is not, when we say it's a domain-specific language, usually in use cases outside of Lisp, you think of a toy language that might not have the full constructs.
Yeah, that your coworker came up with because he just learned like some new metaprogramming trick, and then the rest of you have to suffer on the team because he hasn't implemented everything yet.
Yeah,
it's
exactly.
Not that.
It's not that. Yeah. So domain-specific language here, I think, specifically means in a Lisp-like sense, meaning that you actually have all of the control flow structures that are normally available to you in a Lisp. It's just that you use this basically as a library, and when you use this library, it is able to understand what parts are happening on the server and what parts are happening on the client, and like you said, draw that seam through the AST and distribute the computation to the appropriate side.
Yeah, and one of the interesting claims is the distributed closures, because in our Corba episode, like one of the issues with sending objects over the wire is that if the objects are pointing to other object or if they're pointers, then how do you actually like deal with sending that over the wire? It just doesn't really work very well. But here, it's saying that what they can do is wrap up a closure, which can also be represented as a DAG and send that over. So it's not just values that can be sent over, but entire DAGs that can be sent over the wire, so that it's actually the DAGs are dynamic in that their structure changes as the computation goes on. And for those of you that are interested more in, it's a self-adjusting computations, and we'll put links in the show notes, but like Jane Street has a lot of information on this sort of stuff, but that's effectively what it's doing for the distributed closures. You also remember our Unison episode, right? Like we're back on our game. We're referencing previous episodes left and right. But like in our previous episode for Unison language, like they come at it in a different thing where every function is content addressable. And because of that, every function is immutable. And therefore you can just send them around. And that's the way that they distribute computation across a network of computers. But this is a little bit different, right? Like you're able to wrap up the closure and send it across as a DAG. So that's the killing. So I thought that part was pretty interesting as well.
Yeah, so I think that it's a very powerful concept. Generally, I think that the idea of manipulating ASTs, abstract syntax trees, and using compilers to take one domain-specific language and then compile that down into another representation, which then gets run automatically, is a very powerful idea, because this is also used quite frequently in machine learning. So for libraries like TensorFlow and Torch and things like this, you write your machine learning code in kind of an imperative-looking format, and then there is a compilation step which translates this also into a DAG, basically a computational graph, which then can be scheduled and run on things like TPUs, which are tensor processing units. These are machine learning optimized chips. And so you as a programmer don't have to worry about how to write the code in a way that is optimized for running on these chips. You just write it a program as you normally do, and then a compiler basically does what Hyperscript is doing, which is to take your
Hyperfiddle.
Sorry, Hyperfiddle is doing.
Right.
And so basically, you as a programmer, you write very normal looking code, and then a compiler then comes, understands your intent basically, and then schedules a computation appropriately. In this case, Hyperfiddle is scheduling it across a network.
Yeah, have you heard of Alan Kay's, I think, STEPS Institute? Or like his previous like YC funded research lab. Do you remember that at all?
Mm-hmm, yeah.
So one of the things that Alan Kay does is he comes up with these really deep ideas, but then he presents them in a presentation that with unintelligible graphics, and so it's lost on a lot of people. But I think after watching a couple of things, like I think there's this core idea of like we're building stacks and stacks of software on not very good and solid foundations, and so the millions of code that we have is akin to how the ancient Egyptians just brute forced a tall building by stacking stones large, like wide and high, rather than like trying to figure out like general principles like arches and like I don't know anything else about architecture besides before what I guess like they use buttresses before we figured out like how to make steel, I guess, to put it inside of concrete so we can build higher. And so his claim is that in order to reduce this mountain of code so that it's not millions of lines of code, what you need to do is separate out different layers into different domains and then have a compiler at each domain so that you can keep building upon that. So they did like a little demonstration of that where you were able to do a graphics engine with a minimum amount of code because they kind of had a compiler for those core math concepts. And so I wonder if your tie into machine learning was because of that, because of what Alan Kay was saying. Like I was like, like Shri got it.
No, I didn't know about that specific Alan Kay quote, but I mean, generally, everything is secretly a compiler, and everything is secretly a domain-specific
or a database,
language,
right?
Or a database.
I mean, that's why there's that conference called "Have you tried rubbing a database on it?" So, like, yeah, like if we can't solve this problem, maybe we can turn it into a compiler or a database. So,
I mean, yeah, this is basically what Hyperfiddle is doing, right? They've rubbed a database on it, which is your first point, and then they've also rubbed a compiler on it, and with those two powers combined, it seems like they've come up with a pretty interesting way to simplify making, CRUD apps.
Yeah, and this is not just like something that we're pontificating. The claim is with Hyperfiddle 2020, that thing was 18,000 lines of code plus reagent plus React. And Hyperfiddle 2021 is looking to be about 2,000 lines of code with Photon and Missionary. And Missionary is like a streaming library. Photon is the language, like the network programming language that you use so that you can do this client server in the same piece of code that we've been talking about. So yeah, it seems like if you have a compiler, you can really reduce the amount of code. At least this is one case in point. I don't know how applicable it is across the board, but Alan Kay seems to think that it is. So yeah, I mean, that's why we thought it was pretty exciting. And so if you, as the viewer, have any comments, please let us know. Like, have you tried Hyperfiddle? Have you had other experiences where you were actually able to use a compiler, like rub a data compiler on it, and you just ended up with a way simpler system? So let us know. Or did it turn out terrible and you just didn't have to deal with it because you were a consultant? So let us know down in the comments.
Yeah.
So yeah. So then this is what's unique about Hyperfiddle, and hopefully like we've gone through it at a high enough level that we can go to the interesting part of our episodes, which is like, what does it let us do that's new? Like what's the new thing that we can do here?
Yeah, I think there's actually a lot of startups now that are basically trying to build visual programming tools to build kind of CRUD apps, especially for.
Are you talking about the low code sort of startups?
Yeah, exactly. Yeah. So there are plenty of those, and I think that I don't know exactly how they're framing the problem, but a lot of the times the complaint I hear with no code or low code type of environments is that you run into some invisible wall in which now that your problem no longer fits into the shape of how they've optimized their programming language or their programming environment, you are constrained. You don't actually you have to start using code, right? But it seems like Hyperfiddle is interesting because I can definitely see that there are some parts of it, like the first point, which is to basically build a UI almost declaratively from the shape of your data, given a data schema, could be simplified so that you can actually just point some tool, some GUI at your database, and it will potentially generate a UI for you, or make it very easy to build
generate
a UI.
the app, right?
Generate the app.
It's effective.
Yeah.
Like it's an app builder, for the lack of a better word, because like it's like based on a schema, you get a UI, and so I guess you could just claim that that's an app. Although like the graphic design part and the UX is a different story altogether, which I don't think they have tackled yet. But like the controls the UI controls are definitely there.
Yeah, I mean, and if they steal some ideas from Webflow or something, you can get the UI theming as well.
Yeah.
So I could definitely see that there is an opportunity to use this for the kinds of things that people are using the no code and low code for. But what makes it interesting is that there's potentially an escape hatch, so that maybe you just have a magic programmatically generated app, but as you want to customize it more, or you want to add arbitrary logic, business logic into your app, then you can drop down into Clojurescript and Photon and then enrich your app that way. And because it's all sort of built in this principled way, there isn't this invisible wall that prevents you from graduating from the app builder to the kind of real programming part of the spectrum.
Yeah, and not just that. So Hyperfiddle's library, Photon, is piggybacking off of Clojurescript and Clojure, which is piggybacked off of the JVM. So that means that you can use any of the thing in any of those ecosystems to help you build your app. Kind of reminds me of a sloth. You know that sloth that has an entire like ecosystem of algae and insects in its fur? Kind of like that, a little universe onto itself, piggybacking on piggybacking. But yeah.
I'm sure the Clojure community will love to be compared to a sloth.
And
but in here, we made it
things,
in an endearing way.
Right. I mean, what is their logo? A lambda? I don't know. I think a sloth is way cuter. But yeah, and so I think that it's like in our Zig episode, which we'll link to in the show notes. Like Zig has a very good interoperability story with C, and C, as we know, is pretty dominant. And here, I think Hyperfiddle also has a chance here because they have some sort of interop story as well. And so piggybacking off of piggybacking is not a bad idea at all. So.
Yeah, definitely. And yeah, I think that the really, really annoying thing with a lot of these concepts in the future of programming or in low code or no code type things is that they work really well for the demo that they show, right? Like, oh, here's a magic like chat server, which I wrote using like 10 lines of code because I have a language that happens to be really good at making chat servers or whatever. But then as soon as you want to do anything else, you can't do those things because, like you said, they haven't implemented loops, they haven't implemented classes, et cetera, et cetera. And then also there's the interop story of you can't use all your favorite libraries and things like that. But here it seems like you get all the magic through the DSL, but then you can use JavaScript libraries on the front end because Clojurescript can interop with other JavaScript libraries. On the back end, you have the full Clojure ecosystem, the full JVM ecosystem, so you can basically do anything there. So yeah, I think that there's a very nice story to take something that you build in Hyperfiddle even all the way to production, right? This isn't like for maybe just throwaway little toy apps and toy projects. This could potentially be used in production. And I think actually on their website, they do claim that they have been consulting with a startup and are powering that startup's app. So it seems like they're
internal
targeting
apps,
like internal apps. Yeah. So it seems like they're targeting like a production use case.
Yeah, but then like I guess this goes into a little bit of the nature of abstraction. Like, what is the right boundary to draw for any one piece of code. And so usually I think of abstraction as like when you're driving a car, the mechanics of driving a car is like timing the spark plugs to fire the pistons in order to get the car going, right? But like you never actually want to have that as the UI for the driver to time the pistons, right? Like you wouldn't want like 6 buttons where like you have to like touch them in order to go. Like the UI in the car is actually a pedal where you step on the pedal and then it figures out like when to fire the pistons. And so I think the thing with low code, the abstraction is drawn kind of in a way where where they're taking out details, but it's often taking out details that you may need to use in edge cases. And I think that's why that it often feels like you hit a wall when you make your app and it becomes very bespoke or it becomes more mature. And so I think the reason why Hyperfiddle caught my attention, especially Photon part, is because they've kind of taken a different cut across this abstraction thing. And so instead of saying like, we'll take each part of an app builder, like whether it's like making the request or this component, we'll just cut down the number of details that you need to do. Like instead they identified the part of app building that commonly causes a lot of problems and maybe like a historical accident or maybe a limitation of history, that we have this boundary where we shuttle things back and forth manually, and instead they collapsed that. So and so I think that's why it really caught my eye. And so what do you think about like the right way to make an abstraction? Because a lot of times I think the reason why programming is so hard is because coming up with the correct abstraction in the correct part of the system is a bit of an art and science, and it takes experience to kind of know. And even senior engineers for any particular domain have to feel their way around in the dark for a little bit before they come up with something. So like what do you think about the nature of this, of the abstraction? What sets Hyperfiddle's abstraction apart from like the low code?
Yeah, I mean, I think that the Clojure community and the sort of founder of Clojure, the creator of Clojure, Rich Hickey, they like to focus on this distinction between simple and easy, right? So you can make things simple and you can simplify the problem domain, and that helps in making things easy. Or you can just make things easy, but that doesn't necessarily mean that you've reduced the complexity of the problem in any meaningful way. And I think that
yes,
like low code and no code, what they do and like what you described is that they hide away things in some way.
Make things easy,
to make
but
things
it's
easy.
not necessarily simple, right?
Yeah, exactly. And so it's still built on top of all of the bad abstractions, or just the overly detailed abstractions of the DOM, of making network calls and HTTP, and using traditional databases which have their own sort of model of computation and things like that. And it's basically trying to paper over all of these things to give the illusion to the user that, hey, everything is very simple and you don't have to worry about any of it. But then, of course, if you poke at it enough, then the things start coming apart at the seam.
Or things get knotted up too quickly. Because like you referenced, I think it's a pretty good answer, and maybe I should have thought of it. Or the whole dynamic between us is that I set them up and you knock them down. So good job. But the video that Shri is referencing is, what is it? Simple Made Easy. And it's a Rich Hickey video, which we'll link in the show notes. But like effectively the difference between simple and easy is that simple things are not conflated or complected, because complex is things that are interwoven, whereas simple is not. And easy may not necessarily be, easy things may not be simple because they may be complected. So underneath.
Yeah. So I mean, I think that the reason I think Hyperfiddle could be better, and I say could be because I haven't actually used it, but given the compelling demos that they have, I would say that it gets at the core of what's hard about writing apps, right? Is that there are 3 things actually. We're talking about just client and server.
Are you going to say one thing? It's like my most favorite saying. I should get a T-shirt about it, but let's hear the 3 things, and maybe you'll come up with one of the T-shirts.
No, well, I don't know what you're referencing, but I would say that when you're writing an app, you have your front end, your back end, and your database, and And the nice thing about Hyperfiddle is that it's leveraging Datomic, which we've referenced a bit and before in previous episodes, but we should really do a dedicated episode to it. But my understanding of why Datomic is so compelling is that it gives the client of the database, which is most likely the server, a view of the data as though it is mostly a local object, right? And it uses certain invariants like the immutability to give that abstraction, and that significantly simplifies the way in which you query the database and access the data in there. And so that's one abstraction that makes things really simple, and in other languages is actually quite complex. And then it seems like the other domino that Hyperfiddle knocks down is, again, this client-server communication issue. And you've written a whole blog post about this boundary, the client-server boundary, and all the different abstractions about how to straddle this boundary. And it seems like the issue is that if you don't have a language that is actually aware of this boundary, then you basically have to fire the pistons, so to speak, in your analogy yourself, right? Like you have to think about, okay, well, right here I need this data, and it comes from the server, and so I need to make a fetch and wait for that thing, and et cetera, et cetera. And so the simple answer is to just treat your entire logic as a whole, and then pass it to some other thing, which this compiler, which can then understand where to break it and do it better than you could as a human. And so that's another sort of simplification. And so basically with these two abstractions, it gets at the core of what makes things hard. Querying data is hard, and then making network calls is hard. And by simplifying both of these two things, it gives a kind of very holistic view of your application, all the way from your data store all the way down to your client.
And by hard, we also mean not just the act of doing it, but doing it in a way that is optimized to give a good user experience, right?
Yeah.
And so I think then I think that in summary, like my t-shirt thing would be that web developers are distributed engineers, but we just don't know it, right? And so that kind of gets to the crux of it. Like we are just kind of like manually patching the stuff back and forth, shuttling it between the server and the client and the data, or the server and the database, and like these weird bugs crop up and we forget to do things, and like it's kind of like, if it really sounds like memory management back in the day, and like people are going to be hard pressed to let it go. They're like, well, like back in the day, people would say that like my hand rolled memory management is better than the compiler, and that's really true nowadays. But that said, there are definitely like people that write games that are hardcore about it, or like there is the SIMD where you have to like line up the things so that things are cached correctly and all the caches are warm, and so there is benefit to like managing your memory like layout. But then like doing the manual memory management, most people try to kind of push that to the compiler, and so it is for the networking, it seems. And so I wonder if people have stayed away from it so long because of the 8 fallacies of distributed systems, so that it seemed like, oh, like maybe this is just the nature of thing. Why try? Maybe that's stopped people from doing something about it for so long.
Yeah, I think so. I think that the reason why this might escape those fallacies is that it's entirely managed for you, in that if you write your entire app in Hyperfiddle and use the constructs that it provides, then the compiler actually has a closed system to work with and can translate that into the right sequence of network calls and things like that.
Yeah.
And so I would say that it's probably escapes these fallacies because it's a closed system. I wonder what would happen if you were using some other library which doesn't use Hyperfiddle but also makes like network requests and things. It's the same way that like if you're using a garbage collected language, but then you call out to some FFI, like you can still corrupt your memory and your heap, right?
Yeah,
and so I wonder if some equivalence there.
Yeah, maybe. And the Elm language ecosystem really took a hit because one of its guarantees is that like everything is pure, and so it tried to like fence off the FFI to native JavaScript, and I think that really stunted its growth. But it'll remain to see whether it could just have a future where they just kind of build on everything that's like solid rather than just anybody in the community making things willy-nilly. So back to Hyperfiddle and what it lets us do that it's new. I think it should let us be able to build internal tools and apps that are much simpler, because like now you don't need to do any of that stuff in the middle. Like as long as you're familiar with your database schema, you should be able to just get something up on the page and interact with the database, because effectively that's what we want, right?
Yeah, I think that there are a lot of tools that I write or there are a lot of tools that I want to write that I don't write because
wait, you want to write or you don't want to write?
No, like there are a lot of tools that I wish would exist, but I don't write them because, yeah, it's just such a pain. Like you have to stand up a database somewhere. You have to run a server, and then you have to set up the front end thing, which then communicates with the REST backend and stuff like that. There's just so much like rigmarole to just like getting anything onto the page, like you're saying, and. Yeah, the promise of Hyperfiddle is that I can just write a function. Like basically, my app is a function. Now, where the different parts of that function happen to run, that's not my problem, right? Like maybe it happens in the database, maybe it happens in the backend, maybe it happens in the front end. But I mean, I could write a function, right? Like that's pretty simple. And so
any programmer worth their salt, yeah,
yeah, right. And so yeah, I think that I really like the idea of throwaway tools, like little things that you can write, and because it took so little effort, you don't mind just throwing it away afterwards. And I think there are so many small little apps that people might build for themselves or for their coworkers or for some particular task that they were otherwise doing manually, that
like trolling their coworkers on Slack. Yeah, like I
yeah.
definitely think you can see something like that.
Yeah, exactly. I mean, there's a really good blog post by this author called Robin Sloan called "An App Can Be a Home Cooked Meal," and he draws this distinction between, we think of apps as these professional productions, similar to going to a Michelin star restaurant, right? It's made by professionals, done in the highest quality and standards.
Everything is French Laundry.
Yeah, everything's French Laundry, right? And that's most of the apps that exist are written by highly paid, highly knowledgeable professionals who are similar to those kind of chefs.
Who are willing to take like the extra step to make it such that like they're willing to go the extra, like the last 10%, which is 90% of the cost or whatever, right? And so that's what we get paid the big bucks to do, to cover that last 10%, honestly. Yeah. But yeah, we'll link to it in the show notes. Like an app should be a home cooked meal, right? Because like effectively we invented we invented publishing houses, but like there's no pencil, right? Like you can't jot down a to-do list.
Yes, that's a really good example. Or like we're like the monks of the olden days who would be transcribing books and things like that, while the general populace is illiterate, right? And so yeah, I like the concept of app can be a home cooked meal, because the alternative to a Michelin star restaurant is the meal that you cook at home, right? And it's not like anything dazzling. It's not anything fancy. It might not have all of the bells and whistles that you're used to when you go out, but it's something that you can do yourself, and it's something that you can share with your friends and family. And so to bring it back to Hyperfiddle, I think that if your app can be represented as a function, there are many people who could just write a simple function, then there are many apps that exist that are currently not being shared and made today.
Yeah, I think sometimes there are small ones that I think of, such as Michael Burry, the guy from The Big Short. Mm-hmm. Like he has a Twitter account in which he tweets one or two tweets and then he deletes them. And so you're like, I want to know like what he said way back when. And so I was like, I want to make something where it pulls from the Twitter API and then caches it so that I can like look at it and search for it. But then I'm like, it's like not worth my time to kind of put that together. And then I found that there is a Michael Burry archive Twitter. I'm like, somebody else already does this screenshot. I'll just follow this one, right? And so that's good enough. But then like they're all screenshots, so you can't actually search for it. But case in point, it's just that even if there wasn't that, I probably wouldn't just do it, because it just takes too much effort. Like setting up all that stuff, like the tool chain is just so, I guess like part of it is that everybody is building one part of the tool chain. It's often not holistic. And in some ways this is good because you can mix and match components, right? But then the other part that's bad is that none of these things talk to each other, so you wouldn't gain the efficiency from a holistic solution. And so maybe this is the time is right for some bundling. And so bundling, unbundling. I mean, this also applies. Like in my more idealistic and naive days, I guess I was like, why wouldn't everything be modular? Well, this is the reason. Because like you have to be, if you want things to be modular, you have to be willing to put into the work to like get all these things to work together and talk to each other. And so a lot of the work for us developers now is just integrating all this stuff. And so maybe if there was something that helps us do the integration for us, like we'd be happy to slough it off until maybe such time where we want the modularity again. And so that's where the bundling, unbundling comes from. So which we can link to in the show notes too. There's like a whole blog post about this, I think. Yeah, so I think Hyperfiddle has the potential to change how we build apps in the near term, to get rid of a lot of the inefficiencies of writing web apps, the things that we think of as pain, but we didn't realize it until somebody pointed out that, hey, we keep hitting ourselves in the head with a hammer, and we're like, we thought this was part of the job. So then what about the second and third order effect? Like what's the world look like if everybody jumps on this? Like, I don't think Hyperfiddle would have a monopoly on this idea, but maybe like web app frameworks would start managing networks for you. And so like app developers become actual distributed systems developers, but like they don't know any better anymore. Like they don't have to worry about this, but they can actually be distributed systems engineers now with something like a Photon-like system where the network is managed for you. Like how do you think that world would look like?
Yeah, I mean, I'm really curious about where this compiler magic, like what the limits are of this, because it seems like if you can split app code into two between client and server, then you could split it into n parts, right? Like by induction
parts,
right? Like you can just apply this to all kinds of stuff. So you can fan out computation from your server rather than treating your server just as one single box. Maybe you can fan it out to other nodes. You can represent delayed jobs this way. You can represent all kinds of computation this way. Like I wonder if you could just model entire computation that happens across multiple systems in this way, and the compiler can still do the right thing.
Maybe he'll just turn into Unison. I don't know, but I guess that's the dream, right? Could you write backrub in something like Hyperfiddle?
What's
the
backrub?
Original Google algorithm?
Yeah, that would be interesting,
because
right?
At least Unison, like one of the things that they demoed was being able to write a search engine crawler, a distributed search engine crawler in Unison, because they're able to just distribute the computation across different nodes, and you as the application developer just don't care where it's actually being executed, right? And so here, if Hyperfiddle is able to demo that kind of application, then it really has the potential to grow beyond just doing CRUD apps.
Yeah, I think so. I think a web crawler is definitely a really good example of like an embarrassingly parallel problem, right? Like you can fan this out to any number of nodes. And then, I think that there are even common use cases for just normal web apps, like handling uploads and things. A lot of the time you upload a file to your server, but then you kick off some delayed job, which resizes it into like 10 different sizes and puts it in the CDN and all that stuff. And all of that, like you need to use a separate queue, like library and all of this different stuff. It's a pain. Like I wonder if you could just represent it as a function and have this thing take care of it.
I remember I was building part of this thing because I was doing a fun little app where you uploaded images and resized it, and I was talking to you. I was like, this is a pain. Why did it take me so long? You're like, don't worry. It's just crappy. Everything is crappy, so it's not just you.
Yeah, so I think just generally, I'm excited about Hyperfiddle as it is, but I am really, really interested in just like pushing it to the limit, right? And seeing if you can represent computation generally, like distributed computation generally, using the same model.
Yeah, because then you could conceivably push it into Pied Piper territory where you can write a program. It doesn't really matter where it's actually being executed. You could leverage whatever nodes that are available to your program. And so it's actually cloud as one might just think of it in the abstract, rather than just some centralized server that's like being hosted somewhere by somebody. So conceivably, like it could go into that sort of territory.
Yeah, and we've talked a bunch in like previous episodes about what's it called, like AWS Lambda and these cloud functions and things like that. And there needs to be sort of a coordination layer for this thing, because like if you're going to write your entire backend in this, then you kind of need a holistic view of how this computation is fanning out across all these functions and things like that. And yeah, this seems like a pretty promising direction for a coordination layer that coordinates your computation and takes care of the scheduling. And maybe they run on different Lambda functions. Maybe they run on in the database, in the client, whatever it is. You don't really care.
Yeah, and I was thinking about the coordination. I think the Photon still doesn't really quite take care of the problem of syncing data. Like it's just reliant on the properties of Datomic, where every client could have a copy of that immutable data, and or at least a partial view of that. And so maybe if there are things that are outside of that would still be a problem that need to be solved. But as long as you're kind of within that, because you were talking about like what the limitations are, but I think that should work in there. For me, I was thinking that the second point with the network definitely appeals to me as a developer. But then the first point, where you can just touch different parts of the graph and have it generate a UI, I think that's appealing to me also as a developer, so that non-developers can stop bugging me about things. One of the things when I was working at a company before was that people in finance would always be asking me for numbers, and then like having to just go in the database and write the query for it. Sometimes it's easy, sometimes it's not, and it would just take forever. I just really wish they could query databases themselves. But we know like realistically this is not a thing, because one, learning SQL or like learning whatever Mongo, like whatever the query language is still a little bit too much. And also, you can definitely write queries that bring down databases pretty easily. So we generally don't let people touch that sort of stuff on their own. But like if everybody had a local copy of a specific view of the database, like this wouldn't be a problem. And in addition, if Hyperfiddle lets you, like as long as you're aware of what the schema is, then you can just kind of pick out which parts of that graph database that you want is. And so you could not only get a report, but actually an application where you can go and modify it yourself too, right? And that I think is pretty powerful, because like we have things that are like spreadsheets, which lets us do like organize computation, or like organize data or computation in a grid view, but we don't really have the equivalent for the typical hierarchical data that we have, like that's flying across that wire between our machines, such as like JSON or things that are represented inside of our databases. Like technically, I guess it's a graph, but we often model it as a hierarchy when it comes out of the database. And so like I've often wanted something where it's just a database browser, but you can just, I guess, edit it also, and this is effectively what Hyperfiddle is. It's like a spreadsheet for your database, and I think a lot of people try to do this, but effectively they make like SQL query builders, which is not what I'm talking about. Like what I'm talking about is a way to like not only browse the data that's on your database, but in fact it's generating an interactive interface for you to deal with the data that's on your database. And I guess Access, like Microsoft Access, is like one foray, like a toe dipped in that direction, but we really haven't seen anything since, at least to my knowledge, about what that was. And maybe it should be time for it again. And I don't know, I'm not too versed in that particular space, and so maybe there's a lot of people that's doing this sort of thing already.
Yeah, I mean, I think that all of the examples that you gave of Excel and Microsoft Access and things like that are using the sort of table row relational model of data. But I think that, you know, like you said, when programmers really think about data, like, yes, we do translate our domain, our problem domain, into things like relational tables when we have to, because those are the tools that we have. But more often than not, we are thinking about this like hierarchical or like nested data structures, right? And especially like associative data structures like dictionaries and maps with key value pairs and things like that. And I think that the nice thing about Datomic is that it provides a view of your database that looks basically like that. It looks like a data structure which you can traverse in that way. And so yeah, a lot of the tools that are built on top of relational databases tend to be things like query builders for analysts to analyze like historical data and things like that. and things like Tableau to visualize visualize those queries. But the promise here is that you could allow an equivalent class of people who are technically literate but not necessarily software engineers to maybe even build their own apps or to visualize parts of production data. And by this, it sounds a little scary because like you don't want some random analyst to like write some arbitrary app that touches all your user data, but there are plenty of like
but power to the people. We're talking about we want pencils for everybody, right? So.
Yes. Yeah.
But the safeguard there is what I mentioned before, is that like Datomic, I guess you can think of it almost like Git, where everybody gets a local copy of the set, and you could get like a partial view of the entire thing. And so if you like mess it up or make the query slow, it only affects you and nobody else, right? And so that I think is the interesting part there.
Yeah. I think, just generally, it cuts out this whole boundary between like real production data, which the app is running on, and then all of these like analytics things that happen after the fact. And so right now, all of the focus is on these types of analytics tools because that is what we have the best tooling for. But yeah, maybe we can give power to people to access the real production data.
Yeah. I mean, I guess that comes with its caveats, GDPR or whatever, but
yeah,
we won't cover that here.
Yeah,
we won't cover that here. That's its whole own can of worms. And so are there kind of other things that you think could be applied? Like, are there other types of things besides memory and network that we currently are hitting ourselves over the head with a hammer, but it could also be managed by a compiler?
I'm sure there are lots. But those are the two big problems, right? And maybe some state synchronization is also hard. But
right, and that's definitely over the network too, right?
Yeah,
state synchronization.
Yeah. I don't know. Are there some big opportunities that you see for compilers?
Not off the top of my head, because like you said, I've written some posts to kind of clarify my own thoughts on why is it so hard to build interactive programs, and largely it's like this network boundary is a problem, and keeping state, like managing state is another huge problem. And so I can't quite envision like how a compiler would help you manage state. Maybe constructing state machines, because a lot of times I find that when I'm evolving the data schema for an application, I might start off with like a true false value, and then I find that maybe I need it to be a timestamp actually, rather than just true false, or that like I need to add a third state. And so if I add a third state, now it's like it's no longer like a binary thing. It has 3 different states. That means there's like 3 different transitions. But then when I add a fourth, that like explodes the number. And so like not all of those transitions are valid. So really like I needed something that was a state machine rather than like a binary value, like a Boolean. And so like all languages right now, there's no easy way to transition the data type from a Boolean to an actual state machine with all the mechanics around a state machine. So maybe there's something where it helps that refactor path much smoother, so that you can write something. I'm not sure what the representation is, but like write something to say like this holds a particular type of discrete state, and then as I grow it, like I can add constraints to it, or I add like validation or something, so that like I can grow it smoothly, and then underneath it'll compile it down to like Booleans or whatever else thing, so that I don't need to explicitly say what every transition is, or like what every constraint or like guard for everything is. Like maybe there's some way to construct state machines without just cutting out details, so that they're simple rather than easy, right? So, but I'm not sure exactly what that's going to look like.
I think it kind of makes sense. Like it's kind of like a database migration allows you to specify the diff between your data model, and then it sends the right commands out to the actual database to update the tables and whatnot. But like this is for sort of distributed state that you want to keep synchronized or something like that.
Yeah, and I don't know, maybe it should be one and the same eventually, right? Because right now there's kind of this dichotomy between data that's considered stored long-term and persistent, and data that is in memory. And so with the pattern that I see with Datomic and Hyperfiddle, they're kind of converging so that they could be one and the same.
Yeah, I think that's a general philosophy, right? And you've mentioned this before as like sort of the data, your database shouldn't be a place, right? But a
Right. Yeah.
thing, right? And that's the logical conclusion of that is that there's not really a distinction between the thing that you have locally and the thing that is persisted long term. Yeah.
Yeah. So yeah, I think that there might be something there, but outside of that, my imagination fails me. So I was wondering if you had anything.
So I think there's an interesting application of this principle of compiling, using a compiler to generate a view of data. If you expand your definition of a view to include 3D environments, and so could you use a compiler? Could you rub a compiler on the metaverse? By which I mean that we've talked a lot before about the metaverse is no good, or at least I've said a lot about how the metaverse is no good if all you can do are the things that what the developers would allow you to do, because it's not really a metaverse, it's just a 3D game, right?
Yeah.
And so I can imagine that if you had a metaverse environment which exposed its underlying data model of the world state as maybe a datomic database or something like that, you could build all kinds of things that reflect the state of the world, right? So you could have a lamp which is like a mood lamp. It glows different colors depending on things that are happening somewhere else in the world. And the way that you could do this is that you could represent it as a function of the world state. So I think that if you think about UI not just as building CRUD apps and an HTML type UI, you might even be able to democratize the metaverse by allowing people to write functions which generate a 3D object, maybe even using things like A-frame and other models of representing 3D objects as like a kind of DOM-like model.
Actually, I was thinking that you may not even need to have people write functions, but like just be able to name a data schema. Because I think one of the things that were an objection to NFTs in gaming is that there's like NFTs themselves just holds like a few data points at best, right? And so like the machinery around an actual game is this whole host of code and like usually imperatively around getting a character to run around or even just display on the screen. And so you could potentially like here, because of certain aspects of the datomic model, you're able to take the data schema and plug it right directly into a view. And so if we were to kind of squint our brain a little bit, you could have the view as a 3D model with specific behaviors, such as, I don't know, running, crouching, jumping, or like maybe in terms of, not in terms, so let's back up for a sec. Instead of the animation, think of it about its properties. Have you played Legend of Zelda's Breath of the Wild?
No, but I've watched a lot of videos about it.
Okay. So one of the interesting things about Breath of the Wild is that it's an open world where players can solve problems in their own way, and a lot of times like you can come up with creative solutions to a problem that's in front of you by doing various things, such as like instead of like defeating every enemy, then maybe like you can like catch an updraft with the fire in their campsite and then like shooting a boulder that crushes them or something like that. Like the solutions you have to get around enemies can be completely indirect. And so the reason why you can do this is that every object in the game responds to different properties of other objects in the world. And so the developers for Breath of the Wild talk about the system as a chemistry engine, where in most games we have a physics engine where it's how different objects interact with each other physically. A chemistry engine would be ones where how did you respond to each other in terms of its properties, like material properties. So like if something's made out of wood, like things that have a fire property would burn it, and then if there's water, like it would drench it. And so when you can have these sort of things as properties that can emerge from just the data and being data driven, then you could conceivably just declare the data in the NFTs or in the database. Like it doesn't have to be in NFTs, but like tie it directly to some sort of behavior to generate a view. And the view does not have to be UIs. It could be behaviors in a 3D model. And so in this way, you could conceivably just have data driven objects in your metaverse rather than having to like tie everything manually itself. Because like it
Yeah.
is true for detractors of NFTs that it's true. Like the current state of games is that you very manually tie these things together, and it's a whole bunch of work. But like if you could do the shortcut that the same thing that Hyperfiddle did, because it was able to leverage some properties of the database that it used, like you could conceivably do something like that. And obviously like I'm like waving my hands, and you know it's very outline-ish, but like
Right.
I think you can see the connection that I'm drawing here, right?
Yeah. I definitely see the connection, and I think at the end of the React reconciler episode, you'd shared
Yeah.
the Dwarf Fortress example of the cats
Right.
walking in the bar and licking their paws and getting drunk or something like that. That was the emergent
Right.
behavior, and yeah, I think that there is some connection there. Like if you want people to be able to tie together all the different subsystems of the world to build this kind of interesting emergent phenomenon that makes sense, you might do it in a way where all of these things are part of this giant database, and then you use that data to then dictate the behavior, the movement, the whatever of the objects in that world.
Yeah, so that's one potential for the photon concept, or the compiler, the managed networks, like compiler driven managed networks, to be to change the developing world into the technical world in the long term. Did you have anything else to add to that?
No, that's
Okay.
pretty out there. I have a hard time imagining what that would look like. But yeah,
Well,
it
just
sounds
imagine developing where there's just less bullshit, I guess, because you're just declaring the data, and a lot of that stuff is driven by the data. Like when things are driven by the data, you don't have to hook things up manually. So
Yeah.
I think that if you can imagine that kind of world, that would be pretty interesting. And I guess to that point, one of the experiences I had recently was that I had to integrate with a third-party API, and I really hate doing integration work because it's never like anything that's the actual core thing that I want to be doing.
Yeah.
And then I have to like read a whole bunch of documentation and stuff. And so I was thinking that Hyperfiddle, this idea of managed network, might make API integrations a lot easier, because like it's definitely not a REST API anymore. It's more akin to GraphQL, where the entire object model is exposed to you, and it's up to you to traverse it. And so I think like people really like using GraphQL on the client end, but my experience of setting up the GraphQL API on the server side is still a gigantic pain in the ass. And part of the reason is because the graph traversal that comes in, you still have to realize it in some way to actual Postgres or like whatever relational queries, or like whatever multiple backends that you have. And you have to do it in a way that is efficient, because you could be making multiple round trips to the database yourself on the back end.
Yeah.
And once again, this is all like programmers are doing it manually. And Facebook could do this because it has legions of programmers to do this for you. And it's akin to how their organization is shaped. There is the adage where organizations ship their org chart, and this is never more true than with GraphQL, like, right?
Yeah.
Because like you're able to partition different parts of the object graph to different departments that own different parts of that graph, right? And for like small startups that want to use it, it just doesn't make any sense whatsoever. But, you know, like if successful big companies use it, then it's easy to sell like other people, because we're like a lot of people use the proxy. Like if other people are successful doing it, regardless of what their size is, then maybe we should do it as well, right?
Yeah.
And so I'm thinking that this would be a way to cut that out, so that you can, instead of like integrating with REST APIs by like looking at documentation, you can browse the object model with like a live GraphQL like sort of like interface. Because like GraphQL lets you browse that interface live, right? And then once you have exactly what you want, then you can export that query. But like Hyperfiddle is one step further. Instead of exporting just a query, you can export an entire UI, or like just use that UI itself and then start shaping its presentation to be the app that you want. And so I'm hoping that would make integration life much, much simpler for web developers, especially if a lot of what web development is just kind of slapping this stuff together.
Yeah. I think There's an interesting trend that is going on in web development where there's a little bit of a pushback from all of these big, serious, scalable databases and scalable, production things like GraphQL towards things like, actually, a lot of people are just saying just use SQLite and just put all your data in a SQLite database and co-locate it with your server, and it makes things super simple. And
right.
There's something to it. I'm curious to hear why you're laughing. But, yeah.
No, I mean it's not wrong, but I feel like it's the pendulum swinging too far the other way too. So I mean, like there's respected developers that are like, let's go back to writing raw JavaScript for clients. I'm like, yes, that's my take is that yes, it's for the specific problem. If it's small enough, then yes, that's all you need. But like, it's easy to get to a point. Like complexity ramps up. Like what your T-shirt saying it actually is that complexity ramps up until like suddenly until like nobody can control it anymore, right? Like we should make a more pithy version of that, but like that's exactly what happens. And so I think there's definitely that pushback right now, and I think it's just like rightfully so. I think there is a sudden allergic reaction to like these more heavy things, and like people are like, I'm like, why use SQLite? Like, let's just write to text files. Actually, like I said that once in an interview where like they wanted to like say like write a web app that play Hangman. I'm like, I don't need a database for this. Like, let's just write it to a text file. Needless to say, I did not get the job, but like, I think I was still right there, right? Because like nothing they were doing required a database, because like you didn't need to query it in multiple different ways, and it was known like what the queries are going to be. Like, so like, I think like Hacker News also like writes the files. I get the sense that they don't, like PG did not use a database for that, and so I don't know if it's still like that. So
yeah. I mean, it's not a sense. He literally has told me this way back when, but yeah,
like he doesn't use the database, right? Like he writes a file because like the queries are known ahead of time, and it's not like a guessing game. Like relational databases are really good for when you want to model some like problem domain, like data domain, but like you aren't quite sure like what the future queries are, so you want to keep your options open, right? But I guess he already knew what they were for Hacker News, so it's just like, fuck it, let's write it to files.
So I mean, I think you're right. My quote, and I need to come up with a pithy version of it, is that
so we can
complexity
do
wraps up.
T-shirts, right?
Buy our merch. No, but it's true. But I think that the reason why people are pursuing this direction of like, let's throw away all this fancy stuff and use the dead simple tools is because of what you're saying, that unlike using GraphQL, which is a wrapper over Postgres or something like that, with things like SQLite and text files and things like this, you can give it to somebody and they can look at it, right? Like this is part of the appeal of tools like Dataset and stuff. There's like a whole burgeoning community of tooling around being able to visualize these type of small databases. And so, going back to sort of Hyperfiddle and its promise, it is an appealing concept to just be able to hand somebody what is basically, like, imagine, have you seen those like JSON pretty printer browsers that like you can click and expand like a nested JSON structure and inspect what's inside?
Is it like an app or an online thing? Because the only one I know of is JQ, but that's a command line thing. You're not talking about JQ, right?
Yeah. So basically, like I'm not talking about JQ, but there are like online apps that allow you to visualize like JSON data in an interactive way, right? So imagine being able to give somebody your database in a UI like that, and they can poke around and like traverse all of the data that's inside, and then get a sense of, okay, this is the shape of the data, and then just be able to use that, and no fancy org chart required, no fancy tooling required to then translate that into an application. Yeah, I think like that's a pretty cool direction to go.
Yeah. And so hopefully that's not just true of developers inside a company, but developers outside as well, if when you want to do integration work. So it should be one and the same, honestly. Yeah, so that part is pretty exciting to me, because I hate like, that's probably the second activity I hate doing. Like the first is DevOps, the second one is doing integration with third-party APIs.
I mean, I think third-party APIs is maybe just another specific instance of another type of distributed system which happens to cross cross organizational boundaries. And so I don't know if you can solve the organizational part of it necessarily, but you could certainly solve the if you can get these two organizations to coordinate on using this type of framework to share data and to access each other's data, then you could certainly simplify the integration aspect.
Well, Hyperfiddle's answer to that is having no organization, because I guess if there's no front end, there's no back end, you just don't need those people.
Yeah.
But I mean, like, it really reminds me of Brett Victor's talk on the future of programming. And he had this talk where he pretended like he was a IBM researcher or worker in the 1970s, talking about the future of programming from the perspective of the 1970s. And one of the things he talks about is that surely in the future, for network computers to talk to each other, we don't have developers read documentation out of band and manually write things where computers can talk to each other. I think Hyperfiddle is one step in that direction, or away from that direction, where we do that sort of stuff, where, you know, like, if we want computers to talk to each other, we set up the play for the computers to talk to each other. We say, like, this, we poke around and say, this is the schema, and then they're able to facilitate the actual communication, underlying communication with each other.
Yeah.
And then I guess, like, if we're kind of going one step further, you could conceivably have AGI, like a GPT-3, do that part, right? Where they're poking around, like, given some high level goal, what is the data schema that I need to pull from this API, and then compile that down to the request response that actually needs to happen, so that the human's completely out of the loop. Like, that's the dream, isn't it? Like, that, it should be entirely possible, I think, right? Because you should be able to transcribe, like, given some high level goal as a prompt, give me the data schema that is required from this particular service. And then you can use something like Photon to compile that down into the actual request response of the managed network. I think that's totally possible. Yeah, I think
so.
We've hit it.
That's
the
mean, magic.
I'm like, yeah, that's the magic. Like, I was a little worried there that we wouldn't get out into the stratosphere, but, like, for me, like, that really kicks me out into space, really.
Yeah, no,
in my optimism.
Yeah, there's this old concept, like, for this type of hypertext driven applications called, like, Hatos.
Yeah,
Hatos. Yeah, I've never said it out loud.
Hatos. What does it stand for? Hypertext as a state of I mean, it's a neat idea, but it's,
hypermedia as the engine of application state, and this it's a complex idea, but basically this idea is that you have these APIs that are self-describing in such a way that a program would understand how to traverse, like, get a sense of the data schema, and then be able to make a sequence of requests such that it gathers the information that it needs. So
because you're modeling the entire, like, global state machine as hypermedia text. So, like, there isn't, like, this updating of state in place. Like, updating state means that you're traversing this, like, highly connected graph. So if you're just in a different part of the hypermedia node, then you're in a different application state. And so in order to change state, you follow links or you submit forms. And so that's just the basic idea. It's kind of a neat idea, but, like, wait, why are we mentioning Hatos?
Because it seemed like
you never what?
Oh, no. Yeah, I've never seen it. I've never seen it actually implemented. I've never seen a Hatos application that successfully traverses an API in this magic way, because I think that's not the right model. But I think that if the data is, the data schema is accessible, and you're able to basically pick and choose the parts of the data schema that you want to access, and then use a compiler to generate the application that accesses it, that actually gets you a lot of the way there to the vision of Hatos, which is being able to, given an API or given some data that you want to access, having it be self-describing in such a way that you can actually traverse it in the way that you need in order to generate a particular view or a particular end goal.
So what's the difference between what Hatos provides and what Photon provides? Like, why is the latter more promising? Like, why doesn't Hatos work?
Yeah, I mean, I think one thing is that Hatos requires this request response cycle. It doesn't provide you the data schema up front, right? You discover it by, like, making requests and by finding out what each thing has.
Slow as hell. I think If you look back in the history of like Hyperfiddle, like that's one of the things that they identify, and along with like GraphQL, the designers of GraphQL, like making Facebook, they noticed that in order to represent, if they represented application state as hypermedia, in order to get all the different sections of a web page that is typically like shown, such as like your friends, the news feed, some ads, like you basically have to make a whole bunch of round trips that ignores the network. So yeah. Do you think there's something that we're blind to about a managed network? Like, would one of the 8 fallacies of distributed computing come to bite us in the ass for something like a managed network? Because like one of the things with HATOS that we identified is that if you just pretend the network isn't there, you're going to do things like make a whole bunch of round trips.
Yeah, that's true. I mean, I recently came across this library that people were mentioning on Hacker News called React Query, which I guess now looking at it, they've renamed into Tan Stack Query. Whatever. It's basically a way in which you can manage the asynchronous communication between your server and your client to do things like pagination and network updates, like data updates across the network and stuff like that. And if you look at the scope of the things that it allows you to do, or the scope of the state, like asynchronous state management things that people find themselves doing, there are all kinds of complex stuff. Like there's parallel queries, dependent queries, background fetching, query retries, paginated queries, mutations, query cancellation. These are I'm just like listing a bunch of random.
This is all the realities and complexities of the network coming through, I guess.
Yes, yeah. That's basically what I'm trying to get at. Is like it's not just a beautiful happy path where like I ask for some data, you give me the data, I render the data, right? Like if you look at the kinds of problems that people on the ground, the front end engineers and full stack engineers, the kinds of things that they're dealing with, there's a lot of sort of fractal complexity of like what happens when the server went down and I need a placeholder query, or I want to server side render some query or some data to the client, but then have that update once the page loads or something like that. There's a bunch of these kind of juggling that people are doing, and so I wonder, can Photon handle all of these very obscure edge cases which people are turning to React Query for? And maybe you can, right, with a sufficiently smart compiler, but I think that the scope of the problem space it can get quite complex.
Yeah, I guess it all depends on how good the compiler is, whether it's able to handle that sort of stuff. Because like one of the things about the network is that you get delays or things may never show up and you have no idea why. Like how is that represented in the data model like that shows up? Like I mean, with Datomic, like it does the sync with the database for you, but like if it doesn't have something, I guess there is some delay in the query showing up, and so maybe the compiler finds a way to generate the UI that updates you on the state of the data, not just that it's not here, but that we're currently fetching it, so that you get a sense of the fact that there is a network there. It's not like regular apps where it's either there or it's not, right?
Right.
And so if it was more network aware, then you at least know that we're trying and that this is how long, and then maybe it fades over time and we're retrying or something like that. And so I guess that I didn't see anything in the Hyperfiddle docs that show the attempt to address this sort of awareness of the network from the UI perspective, but maybe that's like future work that they have to do.
Yeah, I'm sure that if their goal is to get this to be used not just in sort of back of the house applications like the internal tools, but instead they want to expand the scope to actual end user facing applications, they would need to handle all these things. So maybe they're being smart in that for things like internal tools, they're typically accessed on a stable network connection, and the users tend to be fairly forgiving of the fact that, if there's an error state, they'll refresh and things like that. So maybe that's why they've scoped it to internal tools. But certainly if you want to take Photon and really push it to the limits of, delivering any kind of application, then I think it would need to handle all of these different edge cases of like, oh, you have a mobile user and they lost reception, and then what happens when they get reception again? How does the UI refresh itself now that the network is present and things like that?
But it seems like it's promising because, like we mentioned earlier, that if you can generate the UI directly from the data schema, like it's not inconceivable that you can also generate parts of the UI based on the network state, because that's just also data about the data, the metadata about the data that's coming through. So that seems like it's entirely possible.
Yeah, and to be fair, like these are hard sounding problems that people are doing manually, but like
hard, they're pretty hard.
They are pretty hard, but the thing is that like compilers do hard things all the time, right? They do all types of optimizations to run on different types of chip architectures. They do all kinds of things. Like on databases, you never think about how the data is accessed, but there is a query planner that knows exactly how to access that data in a very efficient way, probably better than you might be able to manually do it. So all of these
definitely like there's been like thousands, if not like hundreds of thousands of man hours sunk into query planners for relational databases that there's just no way that you would be able to do something better. And I think a lot of people complain how databases are slow, but like if you remember, like this was before my time, but like before relational databases, there were like hierarchical databases, and then people used to write these queries as imperative code themselves to like fetch stuff from disk like that. like that's just, I don't know, that's just that's crazy. I don't know, but basically my point is that like databases do a lot of work to make these things relatively efficient.
So I think I was getting at, compilers are pretty good at doing all kinds of interesting optimizations, and so certainly they could. It's not inconceivable that they can handle all of these different edge cases that we're discussing.
Yeah. I think as long as that, or like what the compiler is doing, is reflected in the UI, so that the user isn't just left wondering what the hell's going on. Because a lot of times compilers are kind of one-shot things right now, where they just compile, and it's okay because they're just kind of self-contained. But if they're compiling for the network, and then the network needs to respond to its like different conditions and notify the user, I think as long as that's conveyed in some way, like this is a promising direction. But yeah, wait till we get that AGI to do the integration for us. I am all for that, because then I can go do other things. Exactly.
Yes.
So how about you? How's your optimism there?
I think it's with Hyperfiddle, as it is with the demos that they've given, I think it's exciting because, again, the whole home cooked meal type apps, there are a lot of apps that I think should exist, that will exist with tools like this. And then with our extrapolation into what does this mean for programming generally, I think that there is a lot of busy work that people are doing, which is going to get alleviated by applying a compiler to do all this annoying stuff. And a lot of people are getting paid a lot of money to do this currently.
On their deathbed regretting all the time that they spent away from their kids when they could have invented Hyperfiddle, really.
yeah. So hopefully they'll feel happy and not regretful. But yeah, I think at least it's promising that hopefully the next generation of web developers will not have to know these pains that we know.
They'll waste their time on other things, for sure.
Yes.
Yeah, so with that, I mean, like, I'm pretty excited and you're pretty excited. So we should take a moment to say that if you, dear viewer, have things to say about Hyperfiddle and you like our channel, please comment and let us know how you like different aspects of this episode or others and how we can improve. Do you like this segment? Do you not? Like, do we need to shift things around? Because honestly, Sri and I have the most fun towards the end, where we're just talking out of our butts, extrapolating into the future. So let us know in the comments, and hit that like, subscribe button, and you should join us next week again for another episode of the Technium, so where we cover another piece and edge of technology. All right, signing off. This is Will.
This is Sri. See ya.
And see ya. Bye-bye.